Well, we're 2 weeks into Christmas season now here at the AirAdjust household, and my to-do list is growing quite long. I should still be able to continue to produce videos on a reasonable schedule, but they may end up having a little bit longer lag between them, trying to get ready for our annual Christmas party. Now, that said, in the last video, I was able to clean up my lazy bit on the ad, and I was able to deal with the issues related with the Z flag. And I discovered something with the carry flag and was not able to get that resolved before the end of the video. So for today's video, I want to focus on that carry flag and make sure that I get things resolved. And then, time permitting, I want to get into the ALU signals and create some LEDs for those. Make sure that I have what I need in place for debugging when I get to the 24 test cases that I've got written. Okay, let's get into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay, I'm going to start today with the build powered off, and I'm on continuity mode here. So when I short the two leads, it beeps. I don't know if you can hear the beep or not, but you can see the indicator go down to 0. Now I'm going to put one lead here on the inverted clock and the other lead over here on the Z flag. And what I thought was a natural clock is actually the inverted clock on the Z flag. Now Z is working okay, so I think I'm going to be good there, but I wasn't prepared for that to be an inverted clock. Now, up here, I had, in all of this ridiculous amount of delay, this signal for the carry flag being delayed, and I think I can plug that in down here on the actual clock and get the signal that I intended. Now this is separated from the rest of those at the moment. And then I don't like the way this looks. I'm having a tough time tracing things because of the way the wires are set. So I'm going to pull all this back out and reconfigure it and hopefully make this a little easier for me to understand and follow. All right, let me get the build fired up and we'll give this a test. Okay, so my attention is focused up here on the carry flag, and that flag is literally the third LED in, and so we'll pay attention to what's going on there. This is a move of the 0 into R1, not the program counter, but R1, move of 0 into R2, add those two together. The 0 flag comes on and latches properly. So that's good. Set carry, so that carry is now set. Move of a constant value into R1, move of a constant value into R2, and then this is my add, and carry turns off, and that is proper. Now, the end flag didn't work the way I wanted it to, and I need to double check that. But both my 0 flag and my carry flag are in fact working properly. Let me pull this apart so I can reorganize it a little bit, and we'll see what kind of damage I can do here. Okay, the signals I am concerned with here are related to the clock and making sure that I have all the different clock signals tied to the proper clock signal. So what I'm going to do is I'm going to start by pulling this out, because I've got one clock signal that's running all the way over here to this latch here, and that is this one. Now I've got the inverted clock running to this location and then off to this location, but I'm picking up that same inverted clock here and taking that off over here to this location, and I need to pull that out cautiously. Now, this should be the clock here, which is coming down here to this NAND gate, over to this NAND gate, and then following on over here to this NAND gate. And this same signal should also be coming over here to these two NAND gates as well. What I think I'm going to do is I'm going to pull from here, bring it up to this location, and then bring it over. Now, I said I was going to clean this up. Okay, so this is the wire I just removed, and I'm going to use it, or reuse it, to jump there. Now, I believe my signal is pin 13, my clock is pin 12, and my result is pin 11, and that looks good. The final change is to jump. No, that's not right. Okay, is to jump there, and that allows me to remove this line. And that should, in theory, work. All right, while I'm digging, I'm going to dress this line up just a little bit. And I will say that it is not easy to strip wires at arm's length. That's for sure. Okay, let me set up for testing, and we'll run this through its paces again. Let's see what we get here. That properly set the 0 flag. That properly set the carry flag. That did not properly clear the carry flag, but it did properly clear the 0 flag. Yeah, the carry flag is clearing, but it looks like it's coming back high. Okay, so that's coming off this latch, this latch, into this line driver, feeding into this latch. I'm looking for the pinout of the 74LS74. So pin 4 is my actual input. Output off this latch, which becomes the input into the line driver, which also becomes the input into the ultimate latch up here. And I still have a timing problem, which is annoying. My 0 flag appears to be behaving properly, but my carry flag is really giving me some trouble here, and I don't understand it. All right, let me try the spike clock. And that spike clock works just fine. So I guess the question then becomes, do I need the spike clock for the N, V, and L flags? Now I can test that, because the N flag should be set there, and it is not. So if I disconnect this and reconnect this one here, and then jump that one over there. So what that has done, and I may have some more cleanup to do, is all of these signals now are based off of the spike clock. So let's give that a shot and see what that does. That worked. That is working. All right. I have to clean this up again. I have to pull this from the spike clock, which means I want to change the color of these wires here. All right, that looks really good now. So before I get into testing the L and the V flags, I want to get some LEDs set up here so I can actually track what's coming in and what's the signals are in this ALU. Let me reset up so that I can start working on those, and I'll be right back. So as I understand it, I have been soldering using the wrong technique. So the technique I understand I am supposed to use is to start with flux, and I will use the tip of a zip tie to kind of spread that out a little bit because I need flux on both sets of pads. And then I am to pick up one of these resistors. Well, that ain't gonna work well, is it? And set it in place. Instead of putting a blob of solder on one of the pads, I am to get this lined up in place on top of the flux, add some solder to my iron, and while holding this down, get it lined up properly. Just tack that in place. Now, other than the fact that I shake too much and it moves around too much, that actually does not look like a horrible joint even yet. I will have to go back and dress that. So I'm going to grab a little length of Captain tape, and I'm only using that because I want to hold this down onto my bed here. And I honestly believe that's actually working a little bit easier for me. Well, let me restate that. It's not that it's working easy, it's not that it's going faster, but I believe the result is going to be better. And the reason I say that is because I believe I'm actually going to get things sucked down to the board better. Okay, those four are now in place. So now I spin it around. Well, I spin it around because I want to be able to get to these easily. And then I pop these in properly. Actually, that one is not quite as centered as I would like. It's like parking a car, at least it's in between the lines. I'm also told that these are not good solder joints because there's just a little bit too much on them, and it does not have that concave joint. It is a convex joint, and that ain't right. Well, and that last one's not even level. So let's see what we can do about this. That's not going to sit down the way I want it to. Now I can come back around and touch these original solder joints up, which apparently I had plenty on to begin with. I'm going to continue on with this, and I'll put you on a higher speed. Well, I also did the LEDs on the other side, plus the pins. Plus I did a second one, and I will say from the other end of this while I am editing, this ends up being a pretty solid technique. I am quite pleased with this, and will end up using this going forward. Okay, I'm not going to say that's the best solder job I've ever done, but as with any new technique, you've got to practice it, and I do believe that this ends up being a slightly better result. The tell will be how flat these are. So if I look down, mostly, there's a couple of them that are out of place. Wow, that last one is really bad. But overall, those look like they are sitting better against the board, which is a problem that I have had for most of my soldering. Now, this one was the very first one I attempted, and obviously I got it elevated a little bit, but most of the rest of those look pretty good. I like this technique better. I'm going to link to Mr. SolderFix in the description. All right, I got more to do. Let me get that all done, and I'm not going to record that. I'm just going to go ahead and knock it all out, and then we'll come back and drop these into place. So here they are. Two 16 gang LED strips. The cathodes are pulled to ground, and I've got 1K resistors on the back, so that should give enough current limiting for the LEDs so that I don't have to worry about them. Driving those are going to be line drivers for ALU bus A, line drivers for ALU bus B. You'll notice I have them inserted upside down. And that is because the inputs are on the bottom and the outputs are on the top, and it's much easier to just jump straight over from here. So I am going to install these upside down. This means at some point I'm going to mess up the wiring on this if I'm not careful. So what I'm going to do during this phase of the wire up is I'm going to spin it around so that the breadboard itself is upside down. I don't have a power rail down here. That's because it's on the build already. I'm just going to sister it up. But this now allows me to drop in all the power and control signals that are associated with the line drivers, get those all settled, and then I can come back and actually do the jumpers from the outputs of the line drivers to the anode side of the LEDs. Now, pins 1 and 19 are the output enable. And pin 1 and ground, which are both corners of the line driver, are going to be what needs to be connected once I get this integrated into the full build. So here's decoupling for each of the ICs, and then some bulk decoupling for the power rails. Okay. And so the only thing that's left here is to go ahead and hook up each of the outputs off the line drivers into the LEDs. Now, since I'm reusing old wires and I have the most green, guess what color I'm going to use for this? Okay, that was fun. Let's get the build out and plug it in. Okay, I'm going to focus down here in the corner. And the whole point of this is to be able to drop this in here. And then theoretically, I should be able to add my hookups for ground and my asserts, but I've got some pretty dense stuff going over here. I had some wires pre-cut for that. Those are not going to work out well. I can get them here. I can get this one. And I can get this one. But the others are going to be a problem. So I'm just going to have to chain those together. So let me get that addressed because I did not check my work. Okay, that should take care of power and ground and get everything hooked up here. This is not ideal, but it will have to do for now. Last thing to do is to hook up ALU A and ALU B into these line drivers. Now ALU B comes into the circuit here, and I'm going to relocate this up, giving me room to put this there, and drop that into... One of them is not right. I'm not pleased with that mess, but it'll at least give me visibility to what's going into the ALU. Okay, let's give this a test. Okay, these two instructions move zeros into R1 and R2. This adds the two together, so these are still remaining 0 and the result is 0. Sets the carry flag up here. An alternating bit pattern into R1. A different alternating bit pattern into R2, such that when I add those together, all the bits are on. But the R1 register goes to ALU A, the R2 register goes to ALU B, and those bit patterns are properly represented down here. Next instruction, deasserts ALU A and ALU B, so these go back to 0 just as I expect them to. So this is a good thing here. All right, next up are these signals here. I've got a 10-way ribbon cable here, and I need to bring those down. I'm probably going to put in a smaller gang of LEDs, not quite 16, probably 8 and 4, so that I could have 12. That way I've got the extra LED ready to go if I need it. All right, I'll be right back. Back down in the corner over here again, and I'm just going to tuck this underneath just to give me some visibility here. I've decided to go with one of these 10 LED bar graphs to match up with the 10 signals that I've got here. So I'll drop these in down here. I've got the cathode side of the LEDs up here. I've got the anode side down here. Now the ALU latch should go low before it goes high. So this is going to be syncing the current. So this is going to be syncing the current. So there's the cathode, and then the anode should be pulled high. See, and that's backwards. The next one is invert, and it should be low all the time. At least at the moment. So when it's high, I want it to light. And I'm going to flip this around again. These two are going to come up here. And I'll put the resistors down here. I don't know why I'm having such trouble with this today. Okay, that's correct. The next two are carry select. I don't understand why that would have carry select be 1. But I'm going to go with it for the moment. The next two are the ALU select on what's inserting out onto the ALU for latching. And that should always be 1, which is correct. Okay, these next two are not yet used. And so I'm just going to tie those as if they're active high signals. And that'll likely have to change. But there's nothing hooked up to those at this point. The next two are, that is the main output enable. That's an active low signal. That's out onto the main bus. And the other one is not used, so I will tie it high, as if it's an active high signal for the moment. Okay, so lastly, I need to deal with the unused AND gates here. And so I will just tie those low for the moment. And let's tie this over here low as well, since it's not being used. And that should clean up that signal. All right. That looks good. I just need to clean up the wiring here. Okay, the last thing I want to focus on is going to be up here in this corner, and that is going to be LEDs for these flag signals here. Now let's see here. I'm going to drop this in here just like that. I'm going to try to keep my head out of the way, but that may or may not be successful. The cathode side of these LEDs are this side, and I'm going to tie those all to ground through a 1K ohm resistor. At the same time, I'm going to add a line driver here. My inputs are on the bottom, my outputs are on the top. The outputs will come up here. And don't forget pin 19 is one of the output enables. Pin 1 is the other output enable. Those are always going to be, helps if you hook it up to pin 1, Adam. Pin 1 is the other output enable, and it's always going to be outputting because it's driving LEDs, ground. And then I've got a 10-pin ribbon cable here, just to make this hookup a little bit easier. Now, I only have 10 signals coming in here that I'm going to track at this point. These are clears and set carry and clear carry and the like. I will have to get these in a separate LED arrangement. But for right now, I want these 5 down here where the Z flag. Now the outputs of these two are going to come here and here. Now the other signals here will be pulled low. Eventually they'll come over here, but I'm going to wait until I get them hooked up before I do that. So that should give me visibility then to my 5 user or program space and latch signals, or latch signals for the flags. I'll pause here. OBS is giving me some trouble. If I power on the build with the OBS running, it actually resets my microphone. I believe it could be because the initial power up of this circuit at this point is drawing so much amperage, it's causing my USB to power off momentarily. And OBS is just not recovering from that. So I have to pause the video and reset in between powering on and powering off. So let me do that real quick, and then we'll come back and give this a test and make sure that I'm getting the flag latch signals up here like I want. Okay, couple of things right off the bat now that I'm powered up. 3 of the 5 that I am interested in are already high, which means that these 2 here I have incorrect. And while I said I was pulling them low for the other signal for a buffer, I didn't actually do that. I left them high. And that's properly corrected. All right, now as I tap my way through this, I think I'm going to find that I've got these LEDs backwards yet again. So here we go. Those are actually low, indicating that my 0 flag and my carry flag are going to be latched at the end of that. So quite literally here, I need to flip this around. and change all of these LEDs to be tied to the 5-volt rail rather than tied to ground. Now with that change made, I need to pull all of these high to indicate that there's nothing going on there. So let's reset and try again. And that's the signals that I'm looking for. Now what I see that I'm missing here is I am not getting signals for N, V, or L on any of my ads. So all 5 of those should be latching, and they're not. So I still have something going on over here with the timing that I'm going to have to look at, or take a look at the actual code for my Control ROM 8 to figure out exactly what's going on there. I'll start with the code and by pulling the CE-PROM and see if it needs to be reprogrammed. It actually dawned on me that this is like the load increment and decrement signals here on the registers now that no longer indicate anything. And that's because over here, they're all using the spike clock. And that signal is so fast that the LEDs don't really have an opportunity to react. Now, the Z and the C flags are using different clocks and therefore do have an opportunity to show up. So what's the solution here? Well, this is where I think the 4-cycle clock is going to come into play, and using that 4-cycle clock is going to allow things to extend longer so that I have more visibility to them. That's not for this video, but that is coming up shortly because I do want to switch over to that at some point here, because this is making me nuts up here. Okay, up here in the corner, I'm going to go ahead and do some cleanup related to the LEDs that I just put in. I'm not going to clean up the control signals yet. I want to make sure that I get through all the testing before I start replacing the temporary hookup wires with something a little bit more permanent, and make sure that everything's working exactly right. I don't want to have to come back and have to change it after I've added in the solid core more permanent wires, if you will. So in the next video, I will take on the 24 or so tests that I have defined and try to execute them one at a time and make sure that everything is going to work properly. I have high confidence in the ad that's finally now going to work right. I am reasonably confident in the Z and C flags, but the N, the V, and the L flag, remember L I introduced as a less than flag. Those 3 flags I need to pay very close attention to. So we're going to take that on in the next video, and then after that we'll take on conditional execution again, where I make sure that all the different conditions execute or don't execute appropriately. We'll see you soon.